Welcome back to Newmber Math, in which we apply color to identify and sequence within Math My Math Through crew. If you've been riding this train the entire semester, guess what? This is your final review, and it is the end of the year as we know it. We will let our sponsors from Tommy Boy, Chris Farley, David Spade, take us home with that one. Kicking it off with number 1, determine whether the quadratic functions will have a minimum or maximum. When a equals positive, the parabola has a minimum function. When a equals negative, the parabola has a maximum function. It's simply just identifying the a for these. All right, so when we are giving this in vertex form here, our function, our a value is that little space between. Okay, if we see nobody home, well, guess what? A equals a positive 1. You don't have to write +1. You can just put 1, but for those that may be first-time viewers, that way you have a little further description in your reasoning and understanding. And when a is positive, our parabola will smile. And this ultimately gives us the minimum, because if we read it from left to right, we're starting up top and we're dipping down into the valley, giving us a minimum. And we will go to answer choice B here. All right, we are given the function now in standard form and the coefficient of x squared. Yes, the number in front of x squared is 3. That is our coefficient of x squared, making a equals positive 3, meaning our parabola again will be smiling and again will be producing that minimum. All right. And answer choices C and D. Well, we just saw standard form, the coefficient of x squared, when the last one was 3, and in this one it is. Wonderful job. Great call. It is -1. Thank you so much. Your input has been awesome. All right. And when our a value is negative, our parabola will frown. But again, if we read that from left to right, we're starting down here. We're climbing up that mountain peak. It's going to give us a maximum. And if we go to answer choice D, we have factored form. And again, we have an a value, and this time it is, yes, it's the negative right there. So a equals -1. And again, our parabola is frowning, giving us a maximum. All right. Oh, bonus question. Which two answer choices do not have a minimum? So we're just looking for the two answer choices that have a maximum. Minimum, cross it. Minimum, cross it. Maximum, write it. Maximum, write it. C and D. C and D. Going forward to number 2. Determine the y-intercept of the functions. Y-intercept equals 0c. Yes, because all of the functions are in standard form, and in standard form, we can easily identify the y-intercept. I have pre-color coded some of these just to speed up the process, as this is a lengthy review. All right, so for practice A, okay, I have pre-colored. Now, our -3 is our a value. All right. Our +8 is our b value, and our +16 is our c value. And if we know it's simply 0 and then c, well, we're going to put 0, comma, and then our c value is 16. Go ahead and circle your answer. At this time, I want you to pause the video if you'd like to practice, write down B, write down C, give them a go, and I will go over the practice when available at the end of the video. All right, moving forward to number 3, determine the vertex and whether it has a minimum or maximum function. All right, so we are given the function here in, yes, vertex form. Great job. And when we're given the function here, all right, we can write the vertex as the opposite value of h and k. But let's first identify, and we'll zoom on in for that. So a is -1. All right, our -12 here, that is your h value, and your +5 is your k. All right, so when we write the vertex, we want to take the opposite of h. Well, if h is -12, what does our h then become? Wonderful job. It does become a 12. Sorry, that 2 just looked like poo. Had to rewrite. And our k value stays the same, which is 5. So we'll go ahead and write that as 12 and 5. All right, but however, it is asking to identify, again, minimum or maximum. And because that is a negative, what's our parabola going to do? So a equals -1. Yes, it will frown, giving us a maximum. And again, at this point in the video, go ahead and pause, look at the example there, and try to work B yourself. And going forward to number 4, determine the x-intercepts. Always know that the x-intercepts represent the x values when y equals 0. For a, f of x equals x minus 8 and x minus 6. The beauty about factored form is that we can easily identify the x-intercepts. Now the x-intercepts are, take a look, so x minus 8, correct? Now if we're looking for x equals when y equals 0, well, we can always just know that that's going to be a 0. Now, however, here's the kicker. We take our -8 and we simply flip the sign, giving us 8, 0, which will make this next one, yes, what do you think it will be? Wonderful, 6, 0. Let's go ahead and close and go ahead, pause the video, and try B independently. Now, as we are hopping along to numbers 5 and 6, yes, we will use the axis of symmetry formula. For number 5, it says determine the axis of symmetry. The axis of symmetry is what x is equal to in our vertex. We will simply apply the formula. So let's rock it through. First thing we want to do is label. Let's zoom on in. Yes, we have standard form. Our 3 is our a value, making -14 our b, and 17 our c. Let's zoom out a little bit as we want to see the formula. We have x equals, we are just going to follow it. I'm going to drop that negative. Okay, and every time we plug into the formula for our simply just b and a, I will put it in parentheses just so you guys can have a more clear explanation, or in case you are using a calculator at home. And we will set that over 2 times our a value, which is 3. We will set this equal to, so once we do negative times -14, well, what does that become? It certainly does a +14, and 2 times 3 is 6. However, we need to reduce our fraction. When given 2 even numbers, I always start with 2. They're both divisible by 2. 14 is not divisible by 3. 4 doesn't work. 5 doesn't work, and neither does 6. So we will use 2. 14 divided by 2 equals 7. And 6 divided by 2 equals 3. Go ahead and circle your answer. However, zoom out, try B independently, and I will go through that at the end. Number 6, determine the vertex and whether it has a minimum or maximum function. And again, we will simply be applying the formula. Okay, so not only are we solving for x, our axis of symmetry, we then need to plug in to find our y. So let's go ahead and label. We have our a, we have our b, and -7 is our c. And again, we're just simply following the formula. We'll put the negative, we'll put our b value in parentheses, excuse me for the hiccup there, and or burp that may have just been released. And we will do 2 times our a value, which is 2 in this case. And -1 times 8 gives us a -8. 2 times 2 is 4. -8 divided by 4 is, yes, -2. I'm going to circle this in orange. I'm going to do so for a reason, and even highlight that in just so you can see how that applies. And we will go through with y equals. Because I did that in orange, every time, we know what x is equal to now. It's open at -2. We are going to take that -2 and plug it back into the function of 2x squared plus 8x minus 7. And I will just go ahead and write that in black as 2. But every time we see that x, we're going to wrap our -2 in parentheses. All right. Follow that through. We will square it because it is telling us to the function. Yes, it is. Plus 8. Again, wrap that -2 in parentheses. Minus 7 equals, and let's just go ahead and pull in our calculator for us. So we will open with a 2, open parentheses, -2, close, hit x squared right there. Boom. Plus 8, open parentheses, -2, close, minus 7. And what do we get for our answer? -15. And I will circle this in orange as well because now we have our x and our y, making our answer simply -2, -15. Go ahead and circle your answer. However, if you'd like to pause the video and try B independently, please feel free. Ooh, I forgot about the min or the max. What is our A value here, guys? Yes, A equals a +2. So our parabola will smile, giving us a minimum. Sorry about that. Number 7, if Mr. Richards hit a weak fly ball, that can be demonstrated by the equation h of x equals -x² plus 8x plus 6, where h of x is the height of the ball in feet and x is the number of seconds it took to cross home plate. Yes, Mr. Richards used to stand back in the batter's box. All right, he used to like to see that pitch dip in case it was off speed or have an extra split second to catch up on that heater. At what point does the ball officially count for distance traveled? So after Mr. Richards makes contacts, it crosses home plate. That's when we will find our y-intercept. And we can simply just go through this in black and white. And I'm sure that you're all comfortable by now with your A, B, and C. And if our y-intercept tells us to do 0C, we've already identified C as 6. Go ahead and circle your answer or circle letter choice D. All right, so number 8, moving forward, I will have to enter this into Desmos. Do I need to? No, not necessarily. Can we speed up the process? Yes, we can. -2x² plus 34x minus 104. -2x² plus 34x minus 104. -2x² plus 34x minus 34. -2x² plus 34x minus 104. We are simply looking for the vertex, and we know it's going to frown, and we do get 8.5 and 40.5. Let me go back into Notability. We will circle answer choice C as 8.5 and 40.5. All right, a bottle rocket's path can be demonstrated by the equation h of x equals -2x² plus 34x minus 104, in which h of x is the height of the rocket in feet and x is the number of seconds from the start of the launch, which point clearly shows the maximum height of the rocket. I'm sorry that I did not read it aloud. For these word problems, you will have to read them because we need to determine what point it's actually looking for on our parabola. Well, if we're looking for the maximum height of it, we're looking for the vertex. So if I'm a student here taking tests and I'm looking for maximum height, I'm just going to put a little star and I'm going to put vertex. And then we will circle our answer. Now, number 9 here. A stone from a slingshot can be demonstrated by the equation h of x equals -0.75x² plus 10x plus 18, in which h of x is the height of the stone in feet and x is the number of seconds from the start of the launch. At what point does it land and hit the ground? Round to the nearest tenth it's telling us, and let's go ahead and put in that function -0.75x² plus 10x plus 18. Let me find our Desmos, and let's go ahead and put that in -0.75x² followed by plus 10x plus 18 plus 10x plus 18. Gotta repeat that so I don't forget. Plus 10x plus 18. And let's put in the plus 18. And let's go ahead. Now, when we read that word problem, we know that we needed to find when it landed. All right, so, man, I really slung that slingshot up in the air, and it started... I pulled back. We start recording here at 0 on our y-intercept, which is 0.18, all right? And that path leads us up to the vertex, but now we've reached a peak, and it has to come down. And when it comes down, it wants to come down and hit that x-intercept. That's our ground at 14.94 and 0, so it will be 14.9 and 0. Again, that's answer choice D. Circle your answer. No, it's not 15 and 0. 0.18, well, yes, we can eliminate that right away because it has to be a number followed by 0 on our x-intercept. Now, number 10, provided f of x equals x², write the shift in the vertex for the following. Function is HK, vertex opposite HK. Flip the H value. The shift is simply left or right. All right, so first, again, let's just simply identify. All right, we have our H here. Now, our K would be right here, and if there's no K, that equals 0. All right, so we're given our function. We need to write the vertex here. Our vertex then is simply, yes, flip that h. So instead of positive 5, it's negative 5. And if our k, there's nobody home, well, we've just put in a 0, and all of a sudden it's negative 5 and 0. And if we're on looking at our graph here, and we're just hopping which direction to the left 5, so this negative 5 in the x spot, because the negative 5 in the x tells us vertical, are we going right or left? Positive, it goes right. Negative, it goes left. So it shifts 5 units left. All right, now go ahead and pause the video. I want you to try B independently. All right, number 11, provided f of x equals x squared. Write the shift in the vertex for the following. Now, when we don't have our parentheses like we did above before, yes, that is negative 10, so we don't have an h value. All right, so if we don't have an h value, well, guess what? Again, just like we didn't have the k above, it's simply a 0, followed by k stays the same, which is negative 10. Close it. Now, our k runs vertical, up and down, and when it's positive, it goes up, and when it's negative, it comes back down. So at 0 and negative 10, our shift is 10 units down. Sorry about the W there. Go ahead and try B independently. Number 12, provided f of x equals x squared. Write the equation for the following translations of g of x if f of x. All right, so just going through this real quick, we have left 6 units, up 11 units. Ooh, okay, so let's take a look here. Let me write this out for us. We have left 6 units, all right, and we have up 11. But we are yet to write where we have flipped the h value. So our g of x is going to equal, yes, what will it equal on the inside? Go ahead and say it aloud. I think that we might have it. X plus 6, great job on the flip. All right, squared plus 11. So once you can read that as left 6 units, well, we know we're going left 6, then just convert that into our function. All right, do the exact same for B. Pause the video if you'd like to try independently. Not the greatest explanation there. Could have went over it a little bit better, but we need to move. All right, so 13, again, I pre-color coded, determine the greatest common factor for each expression. All right, so I've grouped this into, yes, our numeric value for our GCF, and we will look at between 30, negative 10, and 45. All right, if you go to your factors chart, if you're uncertain, they're all divisible by, yes, 5. All right, now I'm going to zoom in real tight here. We have x to the 6th, x to the 5th, and x to the 4th. Well, we need to figure out how many x we can take from all of them. Well, if I try to take x to the 6th away from x to the 4th or x to the 5th, there's too many. I couldn't even take away that much. But I can take away x to the 4th from all of them. All right, now we have y to the 4th, y to the 2nd, and just y. How many y can I take from all of them? Yes, great recognition. A single y. Go ahead and circle your answer. Go ahead and try B independently. And number 14, factor the trinomial, x squared minus 14x minus 51. All right, first thing we always like to do is label. All right, we're going to go back to black and white. We have A, we have B, we have C. Up top in our x factor, A times C, 1 times negative 51 is negative 51. Our B value is negative 14. All right, our factors we need of negative 51. So when A times C is negative, our B value is also negative. The greatest of the two factors that you will select from needs to be negative. All right, so I know a 2 doesn't work. We're already not using 1 and negative 51. Let's jump to 3 times negative 17. Oh my goodness, is that a winner? Yes, it is. We will write that as 3 and negative 17. I'll put that in the box. Reason being, we know when multiplied, it gets us to negative 51. But 3 minus 17 also gets us to, yes, negative 14. So then when we write our answer out, it will simply be x plus 3 and x minus 17. Go ahead and circle your answer. All right, and moving forward, factor the expression x squared minus 81. All right, so you can do this multiple ways. You could do it this way and then go back and do all that. But no, let's just go ahead and write it. It's negative 81. We're going to do x plus 9, x minus 9. Circle your answer. All right, so when you have the perfect square, if it was, let's just say, negative 144, it would be x plus 12, x minus 12. All right, and factor the trinomial x squared minus 12x plus 36. We will factor that out again. We can label the a, b, and c. Our a, our b, and our c. We always know up top it goes a times c. On the bottom is our b. We have 1 times 36 giving us, yes, just 36. Our b value is negative 12. Great job. We're looking for the factors of 36 that when combined get us to negative 12. Now, when we have a times c giving us a positive and our b value is a negative, well, it has to be a double negative. So let's go ahead and write off some of these factors. Negative 2 times negative 18. Well, negative 2 minus 18 gives us negative 20. That's not going to work. All right, negative 3 times negative 12. Negative 3 minus 12 gives us negative 15. That's not going to work. We have negative 4 times negative 9. Negative 4 minus 9 gives us negative 13. That's not going to work either. However, negative 6 times negative 6 does give us, negative 6 minus 6 is negative 12. All right, we will simply use negative 6 and negative 6 in our answer. And I'm going to just write it like this real quick for us. Minus 6, minus 6. Again, use your factoring sheet if you feel it's best for you. Moving forward to number 17, factor the trinomial 8x squared minus 23x plus 14. And again, we will zoom in. We will label A, B, and C up top. Again, we do A times C. This time, 8 times 14 gives us 112. Our B value is the negative, Jordan at negative 23. So we're looking for the factors of 112 that when combined will get us to negative 23. And yes, I did use my cheat sheet for this one, so I will just simply write them out. And I will box it and add it to my answers. Yes, boom. Negative 7 and negative 16 are the factors we will be using because when multiplied, get us to 112, and when combined, give us negative 23. We will take it from there, and we will simply rewrite the function starting with 8x squared. We'll do that in gray. Now from here, our negative 7 and negative 16, it splits up our b term here. All right, so we will just write it as negative 7x. I leave a little bit of space because I do know the next step, minus 16x, and then plus 14. Now the first two terms we group together. The second two terms we group together. From here, we just simply find its greatest common factor. And between 8x squared and minus 7x, well, we can only take an x. All right, so we'll divide each by x. And 8 divided by 1 is 8. X squared minus x to the first leaves us an x. Negative 7x divided by x, negative 7 divided by 1 is still negative 7. And x minus x completely cancels out and we can close. Now let's go ahead and negative 16x plus 14. Two even numbers. I always start with the deuce. All right, and from there is the deuce. However, what do we notice? Our first term is negative. When the first term is negative, our greatest common factor will also be negative. I cannot take an x from both because 14 does not have an x with it. So we will divide each by -2. -16 divided by -2 gives us a +8. Don't forget to drop down that x, and 14 divided by 2 gives us divided by -2 gives us a -7. Go ahead and close that. Now, do we have our winners? Let's check it out. 8x minus 7, 8x minus 7. All right, if what is in parentheses is an exact match, we have factored it appropriately. We can write 8x minus 7 as half of our answer. All right, and then the x in the -2 for x minus 2 will give us our second portion of that answer. Go ahead and circle it. Going on to number 18, factor the trinomial x cubed plus 15x squared plus 44x. Oh my goodness, it's not x squared, it's x cubed. X squared, and now all of a sudden our c term has an x? What do we do? What I like to do is I like to take an x out, set it and forget it. All right, let's open, let's open, let's open, let's open. And again, it will simply be the same. A times c, 44. B value, 15. We're looking for the factors of 44. Well, let's just take a look. 2 times 22 doesn't work. How about 4 times 11? Well, 4 times 11, yes, does give us that 44. And 4 plus 11 gives us that 15. So we do have our winners. And they're both positive, so we'll do +4 and +11. Go ahead and circle your answer. Moving forward to number 19, determine the solutions. 3x squared minus 7x minus 6 equals 0. All right, key little factor here that I'm going to do just to show you something. I'm going to highlight this 3 in red because our a value will come back into play. All right, and then I'll just simply do our B and C, not in color. We'll just keep it clean from here on out. And up top, if we do A times C, now it's looking for the solutions, not the factors. 3 times -6 gives us, yes, -18. Our B value is -7. All right, so our factors that we're looking for here that work are -18, and that when combined get us -7. All right, so let's take a look. We have -9 times 2, and yes, that does work right away because -9 times 2 gives us -18, and -9 plus 2 gives us -7. So we're going to use those right away, and let's take a look at how we find these solutions. And again, when in factored form here, we can easily get our x-intercepts, all right, or our part of the solution here. We do the x plus 2, close that off. All right, now we need to flip and take the opposite out. So x equals not -9, but x will equal 9. So let me just write this out. X equals, and I'll put this in blue so you can see that flip, 9. And then x equals not +2, but yes, -2. Great job. From here, because our a value was 3 and it was greater than 1, well, we have to divide each by 3. And when we do that, it gives us, let me switch back to my red, x equals 3 and x equals -2/3. Go ahead and circle your answer. Now again, for number 20, it wants us to determine the solutions of x squared minus 8x equals 48. Oh my goodness, why is that 48 off to the side? Why? Because they want us to move it to make that side equal to 0. And how do we get rid of a plus 48? Yes, a minus 48. What we do to one side, we, yes, do to both sides. So that'll be x squared minus 8x minus 48 equals 0. Now you can label your A, your B, and your C values. All right, so we're looking for A times C, which will give us -48. And our B value is -8. So let me go ahead and put our -48 over here. And again, because a times c is a negative and our b is a negative, well, the greater of the two factors needs to be negative. And let's go ahead and work through a few of these. Let's just say we start off at 3 and 16. 3 times negative 16. Well, 3 minus 16 is what? Minus 13. So then let's go to 4 times negative 12. 4 minus 12 does give us negative 8. And 4 times negative 12 does give us our negative 48. Let's go ahead and box it for the win. And if we go ahead, x, our a value is just simply equal to 1. So we're just going to write it as x and x. And we found our factors of plus 4 and negative 12. Go ahead and, nope, not circle your answer, but get our solutions. All right, so x equals, we will do the flip, which is negative 4. X equals, we'll do the flip, which equals 12. Now go ahead and circle your answers because it wants the solutions. All right, number 21, simplify the radical. Well, let's take a look. We have factors of 45 include 3 times 15. I don't see a perfect square. 5 times 9. I do see a perfect square. All right, so we know that the square root of 45 is equal to the square root of 5 times 9, with 9 being a perfect square. So that makes this equal to, let's go ahead and take the square root of 9, which is 3. Open up your radical, keep the 5 on the inside, and circle your answer. Number 22, simplify the radical of negative 180. All right, so we are going to simply go negative 180. And I'm just going to go ahead and write those the winning factors out for us. As we have 5 times 36 times negative 1. What? 36 is a perfect square. What do I do with that negative 1? Let's figure it out. Let's open up our... Let's write this actually. Let's make it look professional. All right. 5 times 36 times negative 1. Well, we know 36 is a perfect square because 6 times 6 is 36. And our negative 1, well, the square root of negative 1 is simply going to equal I. So what we're going to do is we're going to take the square root of 36, which is 6. We're going to take that square root of negative 1, which we just simply write as I. And what's left underneath that radical is just a 5. Go ahead and circle your answer. Moving forward to number 23, and here we go. All right, we're given 2x squared minus 242 equals 0. The first step we want to do is get 2x squared by itself. What's hanging out with 2x squared? Yes, it is negative 242 or minus 242. We will add 242 to both sides. Go ahead and bring the 2x squared down. Those bad boys cancel out, equals 242. From here, we simply want to, yes, try to get x squared by itself. We have to divide by 2 on each side, leaving us x squared equals 121, and then from here we will take the square root of x squared, giving us x. But what we do to one side, we do to the other, so that will equal plus minus 11. Go ahead and circle your answer. For number 24, we have x plus 8 squared equals 69, 169. We can simply go ahead and take the square root of both sides by adding the radical in there. We can pull that x plus 8 out directly. Equals the square root of 169, which is 13, or negative 13. And then from here, we need to simply get those solutions. So I will switch over to blue and do minus 8. But what we do to one side, we do to both sides. Phenomenal job. Bring your x down, cancel that bad boy out, equals 13 minus 8 is 5, negative 13 minus 8 is negative 21. Go ahead and circle your answer. Moving forward for number 25, and here we go again. We have 4x squared minus 13x equals 10. It wants the solutions again, but we have to shift the 10 over. They're like, oh my goodness, I just want to see you do one more step. I am going to highlight our 4 here, and then we begin. All right, so let me shift this 10 over by taking minus 10, and we're going to squeeze that in, minus 10. And then we are going to, I'll rewrite it over here. If you bring down your 4x squared, bring down your minus 3x, bring down the negative 10 equals, now we have it set equal to 0. All right, from here you can do your ABC. And the reason this works is because it is a perfect square. 4 times negative 10, so A times C is negative 40. Your B value is negative 3. All right, what do I think about to get to negative 40? I'm like 10 times 4, and I'm like, ooh, that's not going to work. Let me show you why. All right, so we need a 4 times negative 10. Well, 4 minus 10 is negative 6. What else do we have? 5 times negative 8. All right, so that will be our winner, is 5 and negative 8. We'll show that there. And then we will go ahead and just simply write that as, hold on, I'm going to do that in black here, but with what's in green. So we'll do x plus 5 and x minus 8. Now we need to get to what x is equal to. Well, we'll do that in blue. So x equals, yes, it's negative 5, and x equals not positive 8, or not negative 8, but yes, positive 8. What was our a value again? Let's zoom on in tighter. A value was a 4. Oh, we had it here as well. The a value is a 4. All right, so I will divide each side by 4, giving us x equals negative 5 over 4, and x equals 2. Go ahead and circle your answer. Number 26, determine the solutions. Negative 2x squared minus 4x minus 70 equals 0. Why do we have to keep on factoring? Why can't this just ever end? I don't know. I don't create these. A times C, but thank you for reaching out so we can get you your video. Your B value is negative 4. All right, when I think of if I'm getting to negative 140, I'm thinking 14 and 10. All right, our B value is negative. We can use, yes, negative 14 and 10. I'm not going to go ahead and just continue to write all the factors out. It's getting a little old. All right, but we do need to identify our A, our B, and our C. That way we can use that A value in just a moment. All right. So let's do this twice. Let's do our X. Let's do our X. Let's do minus 14. Let's do plus 10. All right. Now, in order again to get the solutions, x equals not negative 14, but 14. And then we have x equals not positive 10, but negative 10. And our a value is a 2 here. All right. So what do? We divide each by 2, leaving us x equals 7, x equals negative 5. Go ahead and circle your answer. All right, for number 27, come on, is the factoring ever going to end? I'm sorry, I don't make these, I just roll with the flow. You're telling me we can't factor? Why? Well, let's go ahead and take a look. We have to use the quadratic formula because the discriminant is not a perfect square. All right, so we do have to use quadratic formula. First step we need to subtract 18 from both sides to get this equal to 0. Then let's go ahead and rewrite it as 2x squared plus 7x minus 18 equals 0. I could have shifted that and made it look pretty, but I'm getting a little worn out right now. We have our A, we have our B, and we have our C value. All right, we are simply just going to write this as x equals. We're going to follow this quadratic formula. All right, so the opposite and then our b, so we'll go negative. We'll put our b value of 7. All right, we will put our plus minus symbol. We will open up our radical. And in parentheses, we will put our b value again, which is 7. We will square it. We will then do minus 4 times our a value, which is 2, times our c value, which is negative 18. And we will put that entirety over 2 times, again, our a value, which is 2. From here, we will go ahead and work through. We have x equals negative 1 times 7, giving us negative 7, plus minus. There's a reason to my madness for this. It does want a decimal. All right, and if we do 7 squared minus 4 times 2 times negative 18, and we round that decimal to the 10th, we will get 13.9. We will set that over 2 times 2, which is 4, and then we will just simply write it as 2 separate equations. And from here, we will go orange followed by gray. We have x equals negative 7 plus 13.9 divided by 4. And then we have x equals negative 7 minus 13.9 divided by 4. And then we'll just do a little computation. Negative 7 plus 13.9 gives us 6.9 divided by 4, which equals 1.7. Circle thy answer. And for the next one in gray, we have negative 7 minus 13.9, which equals negative 20.9. Don't know why that didn't switch. I thought I had hit it. Divided by 4, which equals negative 5.2. Go ahead and circle your answer. Sorry for talking so fast. I'm trying to make this quick and fully explainable for your understanding. Moving forward to number 28. Yes, again, we will use the quadratic formula here. All right, but everything's set up. We don't have to shift anything since it's equal to 0. So let's just go ahead and do our A, our B, and our C. Then we'll switch to blue to begin to write it as x equals. Yes, we will do our negative. We'll put in our B value of 3, open up our plus minus, open up our radical, insert again. We're just following the formula, your B value, which is 3. Close it, square it. The formula tells us to. Minus 4 times 7 times C of negative 5. What are we putting that over? 2 times our A value of 7. And let's go ahead and do a little computation. You know what I forgot to do is highlight last time, and we're just going to do that this time, so I'm sorry about that. All right, I did work a little quick. X equals negative 1 times 3, which is negative 3. Bring down your plus minus. All right, now from here, we have to work it just a little bit at a time. All right, we're going to take our 3 squared, and I want you to do 3 squared in your calculator if you're uncertain, but it will give you 9. All right, from here, I want you to do negative 4 times 7 times negative 5. That will give you 140. So plus 140. All right, we will take that and we will put it over, yes, 2 times 7, which is 14. All right, from here, we have to condense it just a little bit. X equals negative 3 plus minus 149 over 14. Now, when we're left with this radical here, and again, I'm sorry I forgot to put that there. God, I should almost go back and remake this, but I'm not going to lie. I'm getting a little tired. Go ahead and add these two together. It gives you the 149. 149 cannot be simplified any further, so we just go ahead and circle our answer, all right? Sorry about that, guys. I should have done a little bit better of a job for you there. I'm not going to lie. I feel kind of bad about it. I know I can do greater, but I am really beat. These do take me a long time, and we still have a lot to do. Well, not a lot left on this one, but a lot for us teachers before we close this semester. All right, x squared plus 729 equals 0. We're simply subtracting 729 from both sides to isolate that x squared equals negative 729. From here, we take the square root of each. X equals, man, I'm getting really sloppy. That's supposed to be a negative 729. And when we have that negative 729, in your calculator, if you take the square root of 729, second x squared, 729, it's a positive 27. However, because it's negative, I just want you to simply write your answer as x equals plus minus 27, and don't forget the I because it's negative 729. All right, and then last but not least, number 30. And this one's going to be a little bit of a walkthrough, but we will get there. All right, we have our A, we have our B, and we have our C. I promise next year I'll start doing shorts strictly by concept. All right, I'll start working on them this summer so you guys can be really fully prepared, have a little more practice, and just keep on rolling like day to day as opposed to these longer entirety review videos. All right, so we did our first step in red and we labeled. In blue, we're going to write it with our quadratic formula. All right, so x equals, we're going to do the opposite of our b value, which we'll take as 6. I just put in the b. All right, add your plus minus, open your radical. All right, our b value is 6, square it, minus 4 times our a value of 2 times our c value of 16. Take that entirety, set it over 2 times a, which is 2 in this case. All right, we've already labeled everything. We're just simply plugging and chugging along. In green here, we'll do negative 1 times 6, giving us negative 6. Bring down your plus minus. All right, from here, we're just going to break it down into 2 steps. 6 squared is 36. Negative 4 times 2 is negative 8. Negative 8 times 16 is negative 128. And we will set that over 2 times 2, which is 4. All right, now in orange, we will do x equals negative 6 plus minus. We're actually just going to do the computation here of 36 minus 128, which is going to give us a negative 92. We will set that over the 4. All right, I'm going to switch to brown here as we continue. X equals, and we will do negative 6 plus minus. Now, negative 92 can be broken down into, yes, there is a perfect square within it, of 23 times 4 times negative 1. Now, 4 is our perfect square. Let me actually get rid of that right there. I'm actually going to put it in gray. All right. So let me box our 4 there, and then our negative 1 I will circle. All right, we do know that the square root of negative 1 is I. So when we write this in our next step here, all right, actually let's set this over 4. I'm kind of jumping ahead of the game. But x equals negative 6 plus minus. All right, now that 4, the square root of 4 is 2. The square root of negative 1 is I. Open up your radical, drop the Jordan 23, and then divide or put that over 4. And for the grand finale, I'll do that in pink. All right, Anything outside the radical might have a greatest common factor numerically, which we have -6 at 2i and 4. They're all divisible by the number 2. So when we write our final answer, it's going to look like x equals, well, -6 divided by 2 is -3. Open up your plus minus. Well, 2 divided by 2 is 1. You can simply just write the I. Open up your square root of 23. 4 divided by 2 is 2. And that will give you your final answer. And that does complete the review. That's 30 bad boys. They align perfectly with the final if you can get comfortable with them. If you need more practice, reach out. Shoot us a comment. We'd be glad to provide some practice for you. But anyways, hopefully this assists you. Sorry about the sloppy end. I am really beat up. But it was an awesome semester. You guys rocked it all year. Thank you guys for everything. Have an awesome one.